We're just going to wait a couple of minutes to see who else comes. Wait to let them join us and get settled. But thank you for being here. We'll wait a couple of more minutes, then we'll start. Okay, I believe we better go ahead. Good evening and welcome. I didn't realize I wouldn't be seeing you, but I'm happy you're here, and I'm glad you decided to join us tonight. I think we're going to have a great program and learn a lot. My name is Beth Causey, and I'm representing the Creation Care Ministries team at the First United Methodist Church in Waynesville, North Carolina. And as a faith community, we're in a congregational partnership with Creation Care Alliance. And Creation Care Alliance is under the umbrella of MountainTrue in Asheville. So MountainTrue has championed resilient forests, clean waters, healthy communities in the Southern Blue Ridge. And tonight's speaker, Josh Kelly, is a field biologist for MountainTrue. He will be speaking about how climate change is affecting the Blue Ridge Mountains, a segment of the Appalachian Mountains in the eastern United States. Josh was born in Madison County. He earned a bachelor's degree in biology from UNC at Asheville. Since 2004, Josh has worked to improve public land management in a number of different roles. He spent 4 years with the Southern Appalachian Forest Coalition documenting remnant old-growth forest. He worked 4 years with Wild Law, where he championed ecological restoration as the new paradigm for national forests. He's worked with MountainTrue for 9 years, where he continues to work to protect and restore the public lands in western North Carolina. Josh will be presenting about 40 minutes and followed by a question and answer period. And if you have any questions, be sure to type your questions into the Q&A feature anytime during the presentation, and then Josh will get them to the end, at the end. Thank you for your presence, and I look forward to learning with you. And Josh, I'm especially grateful for your training and your experience within the wilderness of the Blue Ridge.
Thank you, Beth. That's a very nice introduction there. Hello, everyone, and thanks for spending a Monday evening with us talking about a pretty complicated topic. climate change. I'm going to share my screen here and get going on this presentation. The title of this presentation is How Will Climate Change Affect the Blue Ridge? And just before we get started, obviously need to note that I am a biologist and I am not a climate scientist. I'm not a meteorologist. I'm doing my best to interpret the consensus on climate science for you all, and also to extrapolate that climate science down to the local level here. And truthfully, there are no models that claim to accurately predict local level effects. However, I think we can safely extrapolate a lot of the trends we're seeing regionally and down into the more local level. As Beth mentioned, I work for MountainTrue, and MountainTrue is an environmental organization, and we do champion resilient forests, clean water, and healthy communities. We focus on a core set of issues, including land use, public lands and forests, improving water quality, promoting clean energy, and encouraging civic engagement by citizens just like yourself to help you all create the communities that you want to live in. The focus of today's presentation is the region that we're all probably in right now. Actually, I have no idea where folks are watching from, but I assume most of us are watching from the Southern Blue Ridge, which is this on the area on the map here from Southwest Virginia down to North Georgia, including East Tennessee, a little bit of Northwest South Carolina, and especially Western North Carolina. And the Blue Ridge Mountains are a really special mountain range. As we all know, they're the highest mountain range east of the Mississippi River. And they're very ancient geologically, very complex geologically, a lot of rain and water, and a lot of different factors make these mountains so special. As a biologist, I want to talk about just a little bit about how biologically special these mountains are. They are one of the most diverse temperate regions on the planet. Now, globally, of course, the tropics are where most of the biological diversity is, but once you get outside of the tropics, the Southern Blue Ridge is a real center of temperate biodiversity. We are home to at least 258 restricted endemic species. That's a very old number, actually. It's probably in the thousands at this point, thanks to the work of the All-Taxa Biodiversity Inventory in the Smoky Mountains National Park. Generally, species that are associated with water and high rainfall, like salamanders, crayfish, land snails, and freshwater mussels, have their center of diversity globally here in the Blue Ridge and the surrounding Appalachians. We have very high diversity of plants, fish, and arthropods, including spiders and insects. And we have the kind of ecosystem diversity you might find in a 700-mile drive, just from hiking from the foot of the mountains, say in Gatlinburg, Tennessee, up to the top of Mount Pecan. So we have the kind of diversity you would find on a trip to Maine, just right here at our back doors. So why is there so much diversity here? And this is an important thing to consider when you're thinking about how climate change will affect our region. Well, our diversity results from a lot of factors, but a large range of elevations, which correlate to a large range of temperatures as well, and a diversity of local climates and weather from those elevations. We have a lot of geographic and geological diversity. That diversity in geology of the different rock types leads to a lot of different soil conditions that lead to a lot of different vegetation types. And these vegetation types have very diverse processes, disturbance regimes. It's like sometimes fire, sometimes lack of fire, sometimes very stable conditions, a whole host of different disturbance regimes. We have a lack of glaciation in deep history, and that's really important. That's part of the climate change history of this planet is the glaciation that we've experienced. And we're also near the Gulf of Mexico, which ensures that we get a lot of rainfall, especially in years like this when we have repeated tropical storms coming through, as we've seen in the past couple of months. Looking at, most recently, the Pleistocene Ice Age, there were glaciers all the way down to the southern edge of Pennsylvania, even into Kentucky and Tennessee, western Tennessee. They didn't reach here, which meant that a lot of species were able to take refuge here. Everything under those glaciers got scraped away. There was very little life left over there. And all the life that has recolonized north of here came from places like the Southern Blue Ridge. At the same time, it's a mixing zone for southern species because we're very far south. besides being a great place for biological diversity, it's also a great place for people here. Whether Native Americans or Euro-American settlers or settlers from Africa or elsewhere, the Blue Ridge has always been an attractive place to live because of its fertility, its beauty, its temperate climate. And that has produced a lot of culture in this area, which also makes this area a great place to live. And these are the kinds of things that we want to maintain, even in the face of a changing climate. So how will climate change affect us here in the Blue Ridge? I think we can start with a little bit of the basics of the science globally. So we live in a natural greenhouse. The Earth is a greenhouse. That is the reason we're not freezing to death in space right now. It's because the Earth has an atmosphere. And similar to the way Venus has a very thick atmosphere, of course, and it is too hot for our kind of life. Surface temperatures in over 400 Fahrenheit on places in Venus. They have an extreme greenhouse atmosphere. We have a really nice greenhouse atmosphere that averages around 57 Fahrenheit. And that's due to the distance of the Earth from the sun, the output of the sun itself, the thickness of the atmosphere and the greenhouse gases, a couple other things. But all things being equal, right now, for the past bit, the atmosphere on the Earth has averaged about 57 Fahrenheit. And with this slide and a number of the other slides, I'd really like to appreciate MountainTrue board member Deke Arndt, who is a climate scientist with NOAA. And also want to recognize some of these slides come from the Climate Connection, which is a really nice website that offers up graphics for folks who want to learn about climate change. Some more greenhouse gas basics. There are several major greenhouse gases on Earth, carbon dioxide being the major one, mostly because it stays in the atmosphere a very long time, up to thousands of years. There's lots of natural sources for carbon dioxide, including decomposition of plant material, releases of ancient carbon dioxide from the floor of the ocean, plant, animal, and soil respiration. Of course, when we breathe as people, we release CO2, and of course, plants like to capture that CO2 and release oxygen back to us. We have a nice relationship with plants. And volcanoes also are a geologic source of CO2. And I think if you look at the history of the Earth, all of the carbon is coming from the rocks in the planet, and has been converted into different forms by life, the development of life on this planet. Methane is another really important greenhouse gas. And natural sources include, swamp gas from wetlands, the oceans, also volcanoes, sometimes wildfires, also decomposition. Methane is a very powerful greenhouse gas, but it degrades from the atmosphere at a period of around 10 to 20 years. Nitrous oxide is another greenhouse gas, not nearly as important as the other two. Water vapor is an important greenhouse gas. The difference between water vapor and the others, though, is it's very short-lived. It can literally rain out of the atmosphere. It doesn't stay up there that long, but water vapor can trap heat into the atmosphere. And what we're living through now is an interesting time when people are affecting the atmosphere in a way that we never have before, and probably in a way that no life form on this planet has ever affected. There certainly has been fluctuation of CO2 over the history of this planet, and it's well documented, and we know that temperature has correlated with that fluctuation of CO2 as well. Prior to industrialization, carbon dioxide in the atmosphere was measured at around 280 parts per million, and we have been able to measure carbon dioxide since the scientific revolution. And today, carbon dioxide is around 415 parts per million. So we are getting way up there. And so you can see on that graph what the trends are since about the year zero in the Common Era. So the main source of added CO2 are human sources, mainly fossil fuel burning, deforestation, and cement manufacturing, other industrial processes. Those processes release carbon dioxide that was, in the case of fossil fuels, captured literally in geologic forms, coal, gas. These are what are referred to as lithic forms of carbon dioxide. They were previously captured by photosynthesis and deposited it into stable forms. And we have harnessed those for our energy and releasing them into the atmosphere. Deforestation, of course, is a process of removing trees and and forest and converting them to other uses. And this has a twofold effect of reducing the carbon sequestration, that is the power of the trees of pulling the carbon out of the atmosphere, and simultaneously releasing a lot of carbon as the forests are either burned or decomposed or get into the atmosphere through a variety of methods. The driver for all this are greenhouse gases. That's the GHG acronym you see there. You know, there are other greenhouse gases that are increasing, oftentimes from human activity, but mostly the biggest driver is carbon dioxide. And there are a lot of indicators of what the increased carbon dioxide is doing to the planet and the temperature. We can measure increased average humidity across the planet from increased evaporation, increased ocean temperature, air temperature, melting glaciers, decreased snow cover, increased temperature over land, increased ocean heat content, rising sea levels, decrease in sea ice. These are all metrics, things we can measure empirically, where there's no argument in the scientific community about the trends in these measurements. We could talk about a lot more in this topic. Arctic amplification, loss of glaciers, permafrost, sea level rise, ocean acidification, all these things. But I'm going to focus on local trends that are already important here and will continue to be important into the future. The first trend is that big heating and cold is increasing. It's increasing while big cold is decreasing. So if you see that small graph there, on the left is the climate that most of us grew up with, where the bell curve is at a certain point of average. We're shifting to a new bell curve, where we have more hot weather than we used to have and less cold weather than we used to have. And here's what that shift looks like across the decades. You know, from 1950 to 1980, there it was. And then there's even measurable increase from 81 to 91. A greater measurable increase from 91 to 2001, and an even greater increase from 2001 to 2011. So there were temperatures globally occurring by 2011 that really weren't observed on the planet back in 1980. That's pretty sobering. Just to give you an idea of what that looks like for some local places, between 1970 and 2019, Raleigh-Durham, North Carolina has been experiencing about 15 days later in the calendar where that last 90-degree day could occur. So they're starting to have 90-degree days deep into October in the Raleigh-Durham area. Same thing basically with Atlanta, about 14 days later. When you look at Asheville, North Carolina, there's been practically no change. And in fact, last 85-degree day might be 1 day earlier. So interesting that here we are experiencing less climate change in some of the surrounding areas as far as heat goes. That kind of makes sense when you think about that we're at a higher elevation and that weather and climate are going to interact differently in the mountains than they do in the lowlands. Some of the effects of a warming climate and hotter weather on our natural systems are going to be pretty severe. Plants and animals that depend on cool temperatures will decline as the temperature increases. Drought stress will increase. Even if rainfall averages remain relatively stable, increased temperatures will lead to increased evapotranspiration from the vegetation and declining water tables and increasing drought stress for all the vegetation and wildlife and streams, and even people who need the water. Plants and animals associated with high elevations will be especially hard hit because those high elevations are basically places where they can find cold temperatures. That's why they're there. And conditions for cool water species like trout will decline. That's kind of the natural world and the situation that I'm looking at as a biologist. And so, for instance, here's a spruce fir forest, a photo of a spruce fir forest in the Smoky Mountains National Park. And there's a lot of wildlife that only occur there, like the Carolina northern flying squirrel and the spruce fir musk spider and Weller salamander and a whole lot more. And there's real question as to whether in 100 years we will even have spruce fir around here. If we heat up at a linear rate similar to the rest of the Southeast or the rest of North America, we probably won't have spruce fir here in 100 years. If there are some buffering effects from higher elevation and perhaps increased cloud cover from increased moisture in the air, maybe we still will. But most likely the habitat niche for the spruce fir forest will decline and decrease and possibly even go away in the next 100 to 200 years. So that's what example from the natural world. How about for people? What we can expect in our region here. In the southern Blue Ridge, our region will remain more habitable than surrounding regions. Even if it heats up here, 5 degrees extra temperature here is way more livable than 5 more degrees extra temperature in Columbia, South Carolina, or Atlanta, Georgia, or Birmingham, Alabama, any number of places, not to mention Florida, as they heat up. And they seem to be heating up a little more than we are, as I showed in the previous graphs. I think it's pretty safe to assume that more people will move here to escape climate effects in other places. And this will place greater stress on infrastructure and natural systems as our region becomes more developed and more crowded with people. So these are things we need to consider as we're thinking about how we're going to deal with climate change here. Trend number 2 that's very well documented, very high confidence, 95% confidence or greater amongst the scientific community. Rainfall intensity is increasing. So this is pretty simple. Warm air can hold more moisture as a law of physics than cold air can. The molecules move faster and you can pack more water vapor molecules into warm air because they're moving around faster. And when those rain events happen, there's more moisture in the air to get squozen out. And so what we're seeing is that large events are now responsible for more of our annual rainfall than they were 20, 30 years ago. And they are also, the largest events are also getting bigger. So we're having less of those gentle rains that we remember and more of these kind of tropical deluges. And in the southeastern United States, we're seeing, we've seen a 27% increase in very heavy precipitation, according to the National Climate Assessment. And this is basically a nationwide trend except for Hawaii, but the East in general is seeing more heavy rainfall than the West is. And we already live in an area of high rainfall, so that's pretty interesting for us here in the Southern Blue Ridge. This all goes back again to not only warmer air temperatures, but also warmer ocean temperatures. As ocean temperatures heat up, we're also seeing more evaporation off the ocean. We're close to the Atlantic Ocean and the Gulf of Mexico. This is leading to stronger hurricanes. There is actually no observed increase necessarily in the number of hurricanes, but hurricanes overall are reaching higher maximum strengths, as we've seen last year with Hurricane Dorian in the Bahamas. 2013 Hurricane Haiyan in the Philippines was the strongest hurricane ever recorded on Earth. So again, this is pretty well documented. Another trend we're seeing with hurricanes is rainfall from hurricanes is becoming more intense as well. So sometimes the hurricanes may not be stronger as far as wind speeds, but the flooding effects are getting worse. We're seeing that in eastern North Carolina very strongly in the past few years. So effects of more intense rain that we can predict, and we're already starting to see. Floods will become larger and more frequent. Additionally, landslides will become more frequent. In the natural world, streams will suffer from an increased scour and sediment. So scour is basically, little pieces of debris scraping away the life from the bottom of the streams. The aquatic vegetation and the insects that are at the base of the food chain in streams will suffer. And sediment, of course, can suffocate aquatic life too. And sediment is coming from sources on land, being washed into the streams more because of human land use and these increased rainfall intensities. On the human side of things, we're going to see infrastructure continue to be stressed at a greater and greater level. And we're talking about everything from housing to transportation and much more. So here we have 3 photos of the largest recorded flood in this region, the 1916 flood that was a result of consecutive tropical cyclones hitting our mountains. And these are all photos of what Asheville looked like in the wake of those floods. And then, of course, 2005 and 2004, especially, we had some pretty big floods in Asheville as well that were reminiscent of those 2016 floods. I think even more than floods, I'm somewhat concerned maybe more about landslides. And these are a real danger in the Blue Ridge. And we're seeing a big uptick in these. These photos are from the Peak Creek slide, which is the most deadly landslide in recent memory in the Blue Ridge. This was part of those 2004 tropical storms and hurricanes that came through and actually killed 4 people, demolished a number of houses, injured 9 people. This was in Macon County, North Carolina. But we've seen a lot of these. 2018, a couple people died in Polk County, North Carolina from the remnants of a tropical storm. We've seen a number of slides in Haywood County as well. And Route 9 on the way to Bat Cave. A lot of highways have been closed. There's a lot of examples recently of landslides. And these are two-pronged. They're oftentimes associated with human development, where maybe people will grade in a new road or a new house site in a steep slope. But sometimes they're also just associated with just steep slopes that haven't been graded. So there's an inherent risk, and unwise development practices can make those risks greater. This is a map of landslides across our region, and you'll notice that they're highly clustered in some places. That is partially an artifact of the lack of work done in some of these counties. There was a landslide commission put together in North Carolina following the 2004-2005 hurricane events. And unfortunately, after the recession, the legislature put an end to that program under intense lobbying pressure from the Home Builders Association, who didn't want people to know if their houses were in danger of a landslide or other slope failure event. But clearly, Watauga County, where all that red is, there's a lot of landslide danger there. But I don't think you can say Ashe County next door is necessarily a whole lot safer. All you know is that Ashe County hasn't had a survey. That is a program that MountainTrue would really like to bring back fully across the mountains. And some counties are actually pursuing this on their own because they realize this is a threat to their citizens. Trend 3 is that drought is likely to become more severe. And I've got an asterisk next to this because there is less scientific confidence around this. My personal belief is that during my lifetime, we've seen a lot of severe droughts, and it's very likely that the increasing temperatures we're observing is also playing into those trends. So this is just a map of the last 180 days of precipitation in December 1st, 2016. And I'm going to talk about 2016 as an example because 2016 was the driest year on record for many, if not all, of the reporting weather stations in the region. So some of the impacts of severe drought, stress to aquatic wildlife. So streams, they shrivel up. Some of them go away. They get hotter because there's less flow to buffer from air temperature. There's decreased water availability both for wildlife and for people. And there is more dangerous conditions for wildfires. And I'm gonna focus on wildfire risk. I think that's another one that people are beginning to realize we're not immune from here, even though we live in a generally wet, humid area. There's a long history of fire here. And as the climate warms and as this area becomes more and more developed, there's going to be more and more danger from wildfire, unless we take action. So when you look at a little table of the feedback between global warming and wildfire, you can see there's a lot of positive feedback between things like increased temperature, increased drought. If you happen to live in an area where there's decreased precipitation, which we probably don't, that's also a positive feedback. If you happen to live in an area where there's increased wind strength, which it's unclear if that's the case around here, that's another positive feedback. Increased lightning is very likely under a higher energy atmosphere scenario because lightning basically comes from the differences between the hot temperatures on the Earth's surface and cool temperatures at cloud tops. So the greater that difference becomes, the greater lightning will be and the greater chance for natural ignitions. Models are predicting that we will have a lot more potential for fire in the spring around here. And so spring and fall tend to be the fire seasons here because we have deciduous forest. And when the leaves are on the trees, things dry out more slowly. And humidity is kept closer to the ground by the shade from the trees. But when the leaves are off from late October through late April, even to early May, everything dries out because of the direct sun, especially if there's any sort of drought. So you can see basically what you need to know here is that from baseline 2000 to 2009, things getting darker means there's more fire potential. That's basically what you need to see. And so across the Southeast, we're going to see greater fire potential. And if you're geographically astute, you'll see that stripe of darkness going up the foot of the Appalachian as well. Other part of the story is that autumn is likely to get much more wildfire prone. And so this is just one of the many drought indices that are used by climatologists and meteorologists, the Keach-Byram Drought Index. But the prediction is that there's going to be a very big increase between 2010 and 2060, and how dry things are going to be heading into the late summer and fall around here. And that's what we saw, and we saw maybe a preview of that in 2016. So in 2016, that was the most active fire season in this region since at least 1942. No coincidence there. 1942 was during World War II. Post-World War II, the United States had a lot of aircraft and a lot of equipment that returned from the war that was put towards putting out fires. So we basically used our technology to put out fires since that time all over the country. And unfortunately, we've reached a point now where the environment is at a place where it's nearly impossible to continue to put out all of these fires. And we're starting to see, especially out west, really severe and very large fires. In 2016, over 72,000 acres burned in western North Carolina alone. It was regionally about 150,000 acres. The Gatlinburg fires in Tennessee were the most expensive and deadly in the region in a century. 2016 was the hottest and driest fall on record locally. We had over 60 days without rain. And this is just a map showing how temperature on the left ranked for various weather stations across the region, and precipitation on the right. So you see a lot of number ones of hottest and number one dry around the region. On the coast, interestingly, you saw a lot of number one wettest in green, because they had a hurricane that we didn't get. So what you need to know about hot weather and drought is that it dries out the fuels. And so there are several things that affect fire behavior. 4 things in this triangle, in this diagram. Weather, so how dry is it, how hot or cold, how windy. Topography, how steep or flat is it. Steep areas tend to burn more uncontrollably than more gentle areas or more sheltered areas. Fuel, as in what kind of wood and plants do you have around to burn. And you can see on the left there, you see a pine forest that's mostly grass. And that's going to burn a lot easier, but also a lot less hot than that forest on the lower right-hand side. Is also a pine forest, very similar type, that hasn't seen any fire. It's just covered in shrubs. And those shrubs are going to burn very combustibly if they dry out and catch fire. Of course, in the middle of the triangle is the ignition source, the fire. So we do have some control over 2 of those things. The ignition source, as long as it's not lightning, the majority of fires are caused from human sources in our region. And then the fuel, we can do things to manage the fuel. So like that photo on the upper left-hand side has had controlled burns to reduce that shrubby fuel. And whereas that forest on the lower right-hand side has not had any controlled burns. And important but somewhat paradoxical concept is that fire frequency is inversely proportional to fire severity. And what that means is the more frequently a place burns, the less severely and less intensely it's going to burn, because there will be less fuel built up. This is a picture of the most severe fire I've ever seen. It was on the edge of Linville Gorge Wilderness in 2007, another really big drought year. It was started by lightning, and this area had not burned in about 50 years, and it literally burned down to sand, as you can see here. It was an extremely intense fire. Now, you go there today, and it's kind of an interesting place. It's really rebounded well. Looks kind of like an African savanna, almost very grassy. But you know, that fire in 2007 was a very frightening and severe one, probably damaging in a way that it didn't need to be, just because we had the policy of putting out all the fires in this area rather than allowing some fires to burn and keep the fuel down. And another concept to be aware of is that sometimes severe drought and heavy rainfall can interact in unfortunate ways. And so this is a picture of US 74 in the Nantahala Gorge that had a landslide in 2018, 2 years after there was a wildfire that removed a lot of vegetation from the upper slopes of the gorge. So we had a really big drought in 2016, removed a lot of vegetation that was holding soil in place, and then really big rainfalls on a very steep area with unstable geology, and it led to the road being closed for many weeks. And it's just one of many examples of road closures we've seen from landslides. So all of these factors are likely to interact in ways that some of which we can predict and some of which we probably can't. So, when we're talking about our human response to climate change, there are basically two major categories: mitigation, which is trying to keep carbon out of the atmosphere, perhaps trying to take carbon out of the atmosphere to prevent global warming from getting a whole lot worse than it is right now. And then there's adaptation, acknowledging that no matter what we do, we're already seeing some climate change. And if we don't change our behavior, we're likely to see a whole lot more. And so how are we going to live with those changes? So on the mitigation side, you're talking about energy conservation and efficiency, renewable energy, we're talking solar power, for instance, sustainable transportation, more like trains and mass transit, improve fuel efficiency in our vehicles, perhaps capture and use of greenhouse gases, including the methane that comes off of landfills. We're talking about carbon sinks, and around here we have some really big carbon sinks in the form of forests. Our region has rebounded from about 50% forested in 1940 to over 80% forested today, and we have really important carbon sinks in the form of our forest. And perhaps we could make those even better, but we also need to think about their stability. And we probably don't have a whole lot more agricultural land we can give up, or residential land we can give up to forest. And on the adaptation side, we're talking about land use, where and how do we build? We're talking about emergency planning, upgrades to infrastructure, where do we live, and how are our homes built, and how energy efficient are our homes, and also health programs, because climate change is going to have health impacts, including diseases that are elsewhere in the world that are coming this way, like dengue fever, Chagas, lots of parasites, and also things perhaps like increased mold if we see an increase in humidity. And mold is a pretty big problem around here in a lot of buildings. So this is a relatively old study. This is from 2009 or so. Pardon me, 2004 or so. And it's showing the projected increase in housing density between 2000 and 2030. So we're 2/3 of the way there. I think this is right on track. But basically we're heading from a time in 2000 where much of this area was at lower moderate housing density to a time when we're going to have majority high housing density, including a lot of high housing density right up against our national forest in green and the national park there in beige. And so this is going to have a lot of consequences for the natural world, and perhaps a lot of consequences for people as well. For the natural world, this is likely, unless we act collectively, to increase fragmentation, where natural habitats are no longer connected. And critters like salamanders that once could move around a forest with no problem have a very hard time crossing paved roads in the hot sun, a very hard time persisting in smaller and smaller patches of forest as they break up into residential development. So let's talk about some adaptation strategies for a couple of the things we're going to be facing: increased rainfall intensity and for drought. When it comes to rainfall intensity, we can do several things. We can avoid building on floodplains, building on steep slopes, and building in landslide hazard zones. There are places that seem like pretty nice flat places to build that are out of the floodplain, but they're at the base of a steep slope. Has a high risk of a landslide. So those are all things to be aware of. And of course, floodplains around here are very valuable. We don't have a lot of flat land. Most of the flat land we have is in floodplains. Also, floodplains are very valuable for agriculture. And honestly, floodplains that are in agriculture should probably stay mostly that way. They should definitely not be converted to housing. If they are, we're likely to see increased costs in the form of insurance payouts, injury, loss of life, all sorts of economic and physical hardships from building in those floodplains, whereas we can deal with the occasional loss of crops. It's much harder to deal with the loss of a home or the loss of we can also improve bridges, roads, and other infrastructure that are going to be stressed by high rainfall. And we can have better land use practices, like more vegetation on stream banks. So a lot of stream banks around here, unfortunately, have lawns already all the way down to the stream, or have cattle graze down to the stream edge. And this makes very unstable stream banks that are not only erode and cause a poor water quality and harm to fish and wildlife, but they are much more dangerous in flood conditions. So you really want those banks to hold together during floods, and having more trees and vegetation on stream banks can do a lot of good in a lot of respects. Another example would be to reduce impervious surfaces like parking lots, or if we have parking lots, to make them permeable to rain rather than running off so quickly and causing flash floods. As far as living with fire goes, I already mentioned prescribed fire. This is the idea of setting fires in conditions where we are confident we can control them versus rolling the dice on when there is a wildfire and we probably can't control it. Mechanical fuel reduction around buildings. So this means if you live in the woods, cutting the shrubs and trees back away from your house. This is called creating defensible space around your house. You basically oftentimes want to have a full tree length between your house and the largest, your patch of forest nearby that can catch on fire. Additionally, you want to avoid living in steep areas or areas with fire-prone vegetation. All of these things can be helped by community planning and building codes. Unfortunately, we live in a region of the country where those are not very popular, and there's not much of a communal land ethic. Most people leave land ethics up to individuals around here, and which is great. It's great when individuals have strong land ethics. And at the same time, individual land ethics oftentimes follow community land ethics. They follow the sentiments in their community. There is a really good program for communities and individuals called FireWise, and another program called Fire Adapted Communities, if you'd like to get involved with those and help your community become more resilient to the wildfires that we can be sure will come at some point. So, we have a lot of unprecedented changes coming. Sometimes it seems like humans aren't going to be able, as people, just not going to be able to get our act together. We might just allow runaway climate change. So what cause do we have to hope? Well, I think we can look some to history, and I mentioned that this area is an old geologic area, and we've been through a lot of climate changes in the past over many millions of years. A great example of documenting the history of this area and deep history is the Gray Fossil Site in Tennessee. These are some sinkholes in limestone geology in the Tennessee Valley, just over the mountain near Johnson City, Tennessee, and they're dated to about 4.5 to 7 million years ago by the fossils that occur there and the sediments there. So these are sinkholes that filled in with fossils and sediments and are now, you wouldn't recognize them unless you started to dig, which is exactly what happened during a highway project in Tennessee a number of years ago. Carbon dioxide levels 4.5 to 7 million years ago were over 500 parts per million. Some scientists even suspect they were around 1,000 parts per million, so much higher than we have now. At that time, there were alligators swimming in the Tennessee River, red panda bears were in the trees, and there was a lot of tropical as well as temperate species in the area. And so clearly it's been warmer around here than it is now. And clearly, if you look at the fossils there, many of the species that were, or at least were there at that time millions of years ago, their descendants are still in this area. So this area has been able to be a refuge for many species through warm and cold temperatures over long periods of time. And now, of course, not all places on Earth are as stable and as fertile as the Southern Appalachians. But we really do need to work together if we want to prevent a situation where our climate is a lot more like Florida than it is like the Blue Ridge Mountains. So here's an example of something MountainTrue does to help our streams. We take these stream banks that have been denuded of vegetation, and we put live stakes in them. So these are willows and elderberries and other vegetation that you can cut a stick off of a live tree, take it to the river, pound it in the bank during the wintertime, and it will actually grow. It'll put out roots and grow. So this is helping to stabilize miles and miles of riverbank across the region. And there's lots of little things we can do like that together, but the more we can work together at large scales and collectively, I believe the better chance we are going to have of having a society that is resilient to the changes that are here and that are coming. And I really do believe that if we take care of the land, it will take care of us. If we treat the land in a way that it can continue to provide its sheltering benefits around here and shelter not only us, but all the other species here, I think we've got a good chance of continuing to have a good place to live. But it's going to require making room for not only all the native species here, but a lot more people that are coming, doing it in a way that doesn't damage the natural infrastructure too much, such that our civilization or society is destabilized. Those are my thoughts on climate change in the Blue Ridge. And so now I think it's time for some discussion and questions.
So Josh, we do have a couple of questions in the Q&A. The first one that came through was, can you explain the microburst phenom? And also hear that farmers are experiencing a narrowing window for planting and harvesting because of the amount of rain. Not sure if that second statement is really.
Yeah, I see that. That's from, yeah, Stephen Wall. Yeah, so microburst phenomenon, I'm not a meteorologist, so I am not great at explaining that phenomenon. I'm not even sure I have a great handle on it. However, I think there are times when we have severe thunderstorms, and severe thunderstorms are driven by that temperature differential I talked about between the warm air near the surface and cold air at the tops of the clouds. And the greater that difference, the more severe the thunderstorm is likely to be. There are also times when we have big systems that move through, oftentimes in the summertime, cold fronts. And with that cold air meets that warm air, and that warm air has all that moisture in it, and that cold air forces it out. And it also creates a lot of wind. And sometimes a lot of times microbursts have directional inline winds that can flatten trees and really create some severe events. But really, I would refer you to some weather people for that. As far as farmers experiencing a narrow window for planting and harvesting because of rain, I think that just comes down to, in high rainfall years, it can be really hard, especially in those really fertile bottomlands that were historically likely wetlands. Yeah, it can just be too wet to plant a lot of the time if we have a high rainfall year like we have this year. On the other hand, as far as planting windows getting narrower, I'm not sure that's actually the case as far as temperature goes, because the growing season we're seeing it has increased over a week in this region in the past 30 years. We actually have a lot of the regions moved into a new USDA zone of agriculture. And I see the second question from Philip Gibson asking if I'm indicating that spruce fir forest need to have controlled burns. And I will say to that, absolutely not. Fire ecology in this area is really complex. There are a lot of forests at high elevations and in sheltered places in the landscape, like coves, on the tops of the mountains with spruce fir forest and northern hardwoods forest, that almost never burn naturally. They're very protected from fire because of the cool temperatures and high rainfall and things like that. A lot of fire ecologists estimate that spruce fir forest around here have a natural fire return interval of greater than 1,000 years. So there's no reason to burn those places. The forests that need to burn are the lower elevation ridges that naturally have drier oak forest and pine forest on them, particularly Table Mountain pine and pitch pine. Those are the kind of places that do need to burn and degrade in the absence of fire and become very dangerous for severe wildfires in the absence of fire. So that's a great question. Are there any other questions out there? Just that Q&A box down on the bottom toolbar should work. I'm gonna stop sharing the screen as well. Seems like mostly must not be too many questions. I tend to talk really fast. If anyone would like to go back and look at any of the slides again, happy to do that. Do my best to explain anything that was unclear, or if you disagree with something I said, I'm happy to be corrected also.
And Beth, if you have anything to add, feel free. If there's any more questions, Josh can field those, but if not, we may wrap it up.
And while you're thinking about that, I just want to mention that this is being recorded. We will send out a link to folks. If you know folks who would enjoy watching this and weren't able to be here, please pass it along.
And Josh, I don't know if you're seeing this comment from James Geenan about the WNC Climate Action Coalition's Youth Conservation Corps initiative. It sounds like maybe, James, you're hoping that we can make an announcement about this. I'm not quite sure how to do that.
Yeah, I'm actually not aware of the WNC Climate Action Coalition's Youth Conservation Corps initiative. Sounds like a hopeful program. I'd like to know more. James says you can find it at WNCClimateAction.com. And I want to take down James's phone number here as well, because he left his phone number. I'll give him a call.
Great. Well, if there aren't any other questions, we might call it good here.
Josh,
Hi, Beth.
can you hear me?
I can.
Okay. I just wanted to say the slide on adaptation and mitigation, that was very interesting, and all the different things for the adaptation strategies and adaptations for living with fire. That's some things that I haven't done a lot of reading in, so I really appreciate you going over that, and I hope maybe at some time I'll go back and think about that again. I appreciate that.
You're welcome. I appreciate you for putting this together, Beth. Thanks so much.
You're welcome. A lot of good information.
We have a new question that just came in. What are the best types of plantings around a home or near forest to avoid fire? That's a great question. If you're in a forested area, basically what you want is to keep shrubs and other woody vegetation away from the base of your house. It's very common in suburban areas for folks to put shrubs on the base of their house, around the base of their houses. But if you're living in a more forested area, that can be pretty dangerous if those catch fire. So what I think what FireWise and other programs recommend is to have either grass or mulch near your home. You want something. Green grass is not very flammable, and neither is mulch. So those can be pretty good. Also, good idea to have a hose handy so that if you have a dry conditions and the fire nearby, you can wet down the area near your house. But the best practice is just not to have things close to your house if you can help it.
Josh?
Mm-hmm.
There's a website. It's resistwildfirenorthcarolina.org. It's got a lot of good information about how to protect your home from mountain wildfires.
Great. Yeah, as I mentioned, if you can do an internet search for the FireWise program or the Fire Adapted Communities program and find a lot of good information there as well. Well, thanks so much, everyone. I think we'll call it an evening, and hope everyone has a good night, and take care.
Thank you so much.
Thank you, Ben.